Okay, so we come back again, and they are saying that a car starts from rest, accelerating at 1 meters per second squared for 10 seconds. It then continues at a steady speed for a further 20 seconds and decelerates to rest in 5 seconds. Now they are saying that we should find the distance traveled in meters, the average speed in meters per second, and the time taken to cover half the distance. Okay, so here we can decide to use a sketch or something, and we can sketch it. So by sketching, we'll have a velocity time graph. Because it's about velocity and time. So this is our time. Velocity is here. They said a car starts from rest. This is 0. So since the car starts from rest, it means the velocity at this point. So the velocity is at that point. So let's say it starts from rest. So and then it was accelerating. So it was accelerating. So it accelerated from 1 meters per second for 10 seconds. So they are saying that it accelerates at 1 meter per second square for 10 seconds. So we know that acceleration is equals to velocity over time. So the velocity was given to be 1 meters and the time is 10 seconds. And so this will imply that the v is equals to 80. And so from this basic information, that is just 1 or 10. Okay, let me say, sorry, v, yeah, so the acceleration is 1 and the time is 10, giving us 10 meters per second. So the velocity there is 10. So it means that if we start a move, we move up to a point here, and that point is supposed to be 10. So here is 10, and the time there coming down is also 10 seconds here. So we have something like this. Then they are saying that it then continues at a steady speed for 20 seconds. Steady speed means, so at this point it was horizontal for 20 seconds. So at this point, so let's assume, so since it moved for 20 seconds, adding 20 seconds to this 10 seconds will give us 30 seconds. It then and decelerates to rest at 5 seconds or in 5 seconds. So it then at this point it then comes down. Decelerate means it then comes down like this for 5 seconds. So at this point we add that 5 seconds to the 30, making 35 seconds. So now they are saying that we should calculate the distance traveled in meters. So from this graph, calculating the distance traveled is the same as finding the area of this graph. And so this is a trapezium, which we all know how to find the area. So distance, so that's the A, is equals to half sum of parallels. What is the parallel? The first parallel, that's its length, first parallel line here, 35, plus second parallel line, that is 20, okay, times the height. What is the height? 10. So if we do this and this cancels each other, that's 5 plus this, that's 55 times 5, and that gives us 55 times 5, that's 275. And this is the distance. So they are saying that we should calculate the average speed in meters per second, and average speed, you know, is distance over time. So B average speed equals to the distance, that's the total distance over the time, and then the total distance is 275 over the time. What is the total time? 35. And so this becomes divided by 35. So we have 7.86. Let me just write 86 meters per second or something. Or we can write it as, or 7 whole number 6 over 7 meters per second. So we can leave it this way too. We can leave it this way. Then okay, so we can leave it this way and our answer is still valid. Now we look at the third part of the question, which says that, what did it say? The time taken to cover half the distance. Half the distance. We have a total distance of 275. So half distance equals to half times 275, and that's equal to 275 times 5, and we get 137.5 meters, or is it kilometers? Yeah. So now we go and check. So half the distance actually for okay, let's find the distance for when the car was accelerating at 1 meters per second and see. So when the car was accelerating at 1 meter per second square, the distance is equals to the velocity times the time. We'll just find the area of that part. Let me see. Okay, so the area of it, so the area of that triangle, this triangle, area of this part, so the area of it, area equals to half base times height. What is the base? The base is 10 and the height too is 10, because the triangle, the base and the height are all 10. This place is 10 and this place is also 10, and so we go back and substitute, and then this gives us 50 meters. So this is the distance for when the car was accelerating at 1 meter per second, but we needed a distance of half. So what do? Since the acceleration and the constant acceleration are not the same, we look at it, and the time for this distance, time used for 50 meters is 10 seconds. It's 10 seconds. Now we need to know the time used for the remaining part of the half of the distance, and so the remaining part is equals to 137.5 minus 50, and this is equal to, I think, 87.5 also. Let me see. Minus 50, yeah, 87.5. And so we then look for the time for this particular one, this distance, when the acceleration, when the velocity was constant, or when it was at a steady speed. So now let's go back to our graph and check something. So it was at a steady speed for okay. So now it was at a steady speed for uh 20 seconds. 20 seconds. And so let's go back and check and see. So now we are looking for the so we have a distance of 87.5, but the speed is 10 point it was 10 because it was constant. From the graph it is constant. It is just 10 throughout the whole place. So we are going to use that to calculate the time. So we can say that the time is equal to the distance that we have, 87.5, over the speed, which is 10. And so using our calculator to do this, we are going to have 8.75 seconds. And so we add the two times, this one to this one. So if we do that, so time used for half the distance equals to 10 plus 8.75. This equals 18.75 seconds. That's all for that one. So we continue from the next question.